This is section 7.3, Solving Systems of Equations, part 2. We left off here on the last video. We're going to talk about solving systems by the elimination method. It's also called the linear combination method. In your textbook, it's also called the addition method. It has many different names, but it's all the same method. What this method does is looks for the point where the two lines cross, just like by graphing or by substitution. But notice I don't have either equation solved for a variable. I don't have either x equals or y equals. Notice both equations are in standard form. So what I'm going to do is I'm going to pick a variable, doesn't matter which one, either the x variable or the y variable, and I'm going to eliminate it. In order to eliminate a variable, what I need is the same number with opposite signs. In other words, if this is a 9x, this would need to be a negative 9x. Since it's not, I'm not going to eliminate the x's. I'm going to look at the y's. This is a negative 8. This would need to be a positive 8 for the y's to eliminate. Again, it is not. So what I'm going to have to do is multiply one of the equations by a number so that I do get one of my variables to eliminate. As I look, I notice my y values. One is positive and one is negative. That's a good thing. That's what we need. So that's a start in the right direction. So I'm going to choose to eliminate the y's. It doesn't matter. You'll get the same answer in the end if you choose to eliminate the x's. But since one is positive and one is negative already, that's going to save me a step. So what I'm going to do is figure out what number I have to multiply the 2 by to get a positive 8. If I multiply 2 by positive 4, that will give me a positive 8. Same number, opposite sign, which is a good thing. The only trick is, if I multiply the 2y by positive 4, I also have to multiply the 3x, and I have to multiply the 48. So I'm going to multiply everything in the top equation by 4. So that's going to change my equation. So instead of 3x, I now have 12x. Instead of 2y, I now have positive 8y. And 48 times 4 is not something I know off the top of my head, so I'll multiply that real quick. 8 times 4 is 32. 4 times 4 is 16, plus 3 is 192. Now my bottom equation, I haven't changed. The reason why this used to be called the addition method is because at this point we add the two equations together. I add my x's to my x's, so 12x plus 9x will give me 21x. I take my 8y and my negative 8y and add those together, and that will give me 0y. And I add my 192 plus a negative 24, and again, not something I can do in my head. I get 168. Divide by 21. And you get x equals 8. Once I find my x value, I need to find my y value. So again, I'm going to take my x and plug it into one of the top equations, it doesn't matter which. I will probably plug it into the top equation, it has smaller numbers and no negatives. So I have 3 times 8 plus 2y equals 48. 3 times 8 is 24. Subtract the 24. We get 2y equals 24. Divide by 2. And y equals 12. So the answer, the solution to this system, is the point 8, 12. The number of solutions to a system of 2 linear equations and 2 variables is given by one of the following. Before I go over this table, what I want to do is show you a graph of the way 2 lines can intersect. So let's suppose I have 2 lines and they cross right here. So they cross in one point. They have one solution. One solution. But that's not the only possibility for 2 lines. Suppose I have this line here and this line here. Notice these 2 lines are parallel and they don't ever cross. If 2 lines are parallel, we would say that they have no solution. Remember, a solution is where the lines cross. If they don't cross, they're not going to have a solution. The third possibility, I've got this line here, and I have this line which goes directly over top of the first one. Again, what we're looking for is where 2 lines cross. Since they cross or touch here and here and here and here and here, every single point along the line, we would say it has infinite solutions. Infinitely many solutions. Okay, so basically I drew a picture of the 3 situations that are in the chart. So when you write down the chart, I also want you to draw the graphs of those situations. Here I have a system, which isn't showing up yet. Hold on. There it is. 4x plus 6y equals 12, 6x plus 9y equals 12. And I want to solve it. Since both equations are in standard form, I am going to use the linear combination method, or the elimination method, or the addition method, depending on what you want to call it. Now notice this is a 4 and this is a 6. I can't multiply 4 by anything to get a negative 6. I have a 6 and a 9. And again, I can't multiply 6 by anything to get a negative 9. So what I'm going to have to do is multiply both equations. So randomly, I'm going to choose to eliminate the x's. What that means is I need to figure out a number that 4 and 6 both go into. Well, the smallest number that 4 and 6 both go into is 12. So I have to make the 4 into a 12. I have to turn that into a 12. And I have to take the 6 and I have to turn that into a negative 12. Remember, they have to be opposite signs. To turn the 4 into a 12, I'm going to multiply by 3. So the top equation, I'm going to multiply by 3. The bottom equation, I need to turn that into a negative 12. So I'm going to multiply the bottom equation by negative 2. So the top equation by 3 gives me 12x plus 18y equals 36. The bottom equation by negative 2 gives me negative 12x, negative 18y equals negative 24. I'm going to add those two equations together. If I have 12x plus a negative 12x, that's going to give me 0 x's. If I have an 18y plus a negative 18y, that's going to give me 0 y's. Since everything was eliminated on the left side of the equal sign, I do have to put a 0. 36 plus a negative 24 gives me 12. Now you'll notice that the x's and the y's were both eliminated. And I was left with 0 equals 12, which is clearly not true. 0 is not equal to 12. Since both my x's and my y's were eliminated, and, notice I said and I got a statement that was not true, we would say that there is no solution. This would be a circumstance where if you were to graph these two equations, you would see that they're parallel. I'm going to solve this. I have y equals 3x minus 2, 15x minus 5y, y equals 10. Since my top equation has been solved for y, I'm going to use substitution to solve. I'm going to take my 3x minus 2. I'm going to replace my y value in my second equation. So I have 15x minus 5 has to go in parentheses, 3x minus 2 equals 10. I'm going to distribute the negative 5, so 15x minus 15x plus 10 equals 10. Combine like terms, my 15x and negative 15x become 0. I have 10 equals 10. Again, I had a situation where the x's and the y's were eliminated, but in this case I got something that was true, 10 equals 10. Since my x's and my y's were both eliminated and I got a true statement, I would say there's infinitely